Okay, good afternoon all of you. In this particular session of electrostatics, the MCQ electrostatics session that we are having today. So I am going to give you 4 homework questions from Coulomb's law. Coulomb's law is pretty straightforward, 1 by 4 pi epsilon naught q1 q2 by r square. And what we'll do is that we'll just have a look at these 4 homework questions and I'll just tell you about it. So the thing is that this session that we are having, this is the MCQ session. So obviously in some of the questions you will have to use calculus, some of the questions you will have to use vectors. Okay, that you decide according to the question. So the first question is that there are 4 charges Q, all are Q, like Q, 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 they are kept at the 4 corners of a square. And at the center of the square there is a charge minus q by 4 and each side of the square is of length L. So there are 4 charges small q each, minus q by 4 is at the center, each side of the square is length L. So the question is, what is the force on minus q by 4 due to all the other charges? So the options are q square by 4 pi epsilon naught L square. Second option is root 2 into q square by 4 pi epsilon naught L square. Third option is 0. Fourth option is 2 root 2 into q square by 4 pi epsilon naught L square. So these are the 4 options, 1, 2, 3, 4, right? So I think you must have understood that you have to use vectors, or maybe there's a trick you can think about it, but that trick also will come by some vector approach. Maybe this is a tricky sum, the answer is very easy, okay, but the concept is by vector approach. Okay, so this is question number 1. Now question number 2, there are 3 charges q1, q2, q3 and we don't know whether they are positive or negative. So there are 3 charges q1, q2, q3 and we don't know whether these 3 charges are positive or negative. That information is not given to us. So when q1 and q2 are taken together as a single charge, like q1, q2 together is taken as one single charge, then between q1, q2 and q3 there is a repulsion, right? Between q1, q2 and q3 there is a repulsion, and if the distance is capital L, the magnitude of the repulsion is 2. So it is 2 units, whatever units. Now if q2 and q3 are together taken as a single charge, so you take 2q2, you take q3 and consider both of them together as one charge, then at a same distance L from q1, the interaction between them is attraction and the magnitude is 4. So they have an interaction of attraction and the magnitude is 4. If q3 and q1, okay, if q3 and q1 are together taken as a single charge and q2 is taken separately and the distance is L, then the interaction between them is having a magnitude of 18. So when q1 and q2 together is equal to one charge and distance from q3 is L, then the interaction is repulsion of magnitude 2. When q2 and q3 together is equal to one charge and they have an interaction with q1, it is attraction of magnitude 4. And when q3 and q1 are interacting with q2 distance L, the interaction force, whatever it is of magnitude 18. The question is that with this background, you have to say what is the ratio of q1 is to q2 is to q3. So with this as your starting point, you will have to say what is the ratio of q1 is to q2 is to q3. And the options are 1 is to 2 is to 3, 2 is to minus 3 is to 4, 4 is to minus 3 is to 1, and 4 is to minus 3 is to 2. So these are the 4 options. Then we come to question number 3 of the homework. Question number 3, there are 2 charges, each of them is capital Q and the distance between them is small d. So on the perpendicular bisector, okay, on the perpendicular bisector of this line, there is a charge small q. So capital Q, perpendicular bisector, there is a charge small q. So at a distance x on the perpendicular bisector, there is a charge small q. So what is the maximum force on small q? I mean, when is the force on small q maximum? Options are x is d by root 2, x is d by 2, x is d by 2 root 2, x is d by 2 root 3. So these are the four options. So the force on small q will be maximum when x is d by root 2, x is d by 2, x is d by 2 root 2, x is d by 2 root 3. So these are the options for question number 3. Question number 4. There is a non-conducting rod. Okay, there is a non-conducting rod of length capital L. The length of the rod is capital L, and this non-conducting rod, it contains a charge small q, and there is a charge capital Q at a distance small d from the end of this rod. Like from the end of the rod, capital Q is at a distance small d. So with this background, you have to say what is the force experienced by capital Q. Okay. So what is the force experienced by capital Q? With these details you have to say. So the options are small q into capital Q by 4 pi epsilon naught d into d plus L. Then second option is 4 into small q into capital Q by 4 pi epsilon naught d into d plus L. Third option is 2 into small q into capital Q by 4 pi epsilon naught d plus L whole square. Fourth option is 4 into small q into capital Q by 4 pi epsilon naught d plus L whole square. So these are the four options for question number 4. So these are the 4 homework questions from Coulomb's law, and not much by way of theory that I need to tell you. Is just you have to use the law. In this sum, you have to use a bit of vectors. In this sum, third and fourth sum, you have to use a bit of calculus. Okay. So that will be all for this session. Okay. These are the 4 homework questions. So on that note, I will conclude the session. Thank you. Bye all of you.